Alright, so a bunch of these identities we've already talked about. Right here. There's a bunch. And then also, I didn't put them on here, but those identities with the negatives, so like the even and odd stuff, do y'all remember those? They were on your notes a while back. I don't remember which ones they were, but they were on there. So we might have to use those here in a minute. But basically, all you're doing today is proving identities or just rewriting expressions using your identities. So we did a little bit of that a couple of days ago when you were solving those equations. You had to use a Pythagorean identity, but we're just going to do a whole lot more today. So the first one we've got is cotangent over cosecant. So what I usually try to do is rewrite everything in terms of sine and cosine. Because just about every trig function you have, you can rewrite it with sine and cosine. So I would start there. So what is cotangent? Cosine over sine. So we could say cosine over sine. And we're doing divided by cosecant. So what is cosecant? 1 over sine. And when you're dividing fractions, what are you really doing? Multiplying by the reciprocal. So I'm going to say times sine over 1. That's going to go away. What can we do from there? Cancel your sines, so that whole thing is just cosine. Is that okay? Questions so far? Did we do this in Math 3? No? Okay. Alright, so looking at number 2 there, we've got fractions, and in order to add fractions, what has to be going on? Common denominator. So let's do that first. So we could multiply the whole first fraction by cosine. We'll multiply the whole second one by sine. So we'll have cosine plus sine times cosine. And then that's all going to be over sine times cosine. And then we're going to be multiplying the whole second fraction by sine. So I'm going to go ahead and rewrite that cotangent. What is cotangent? Cosine over sine, so we'll say cosine over sine, and that's being multiplied by sine, so you can have common denominators. I'm using thetas instead of u's. Oops. And then we had cosine times sine again. Minus cosine u sine u over another ring. And all that is over sine u cosine u. Is that okay? Do we have questions so far? So we got to get common denominators, right? So multiply the whole first fraction right here by cosine. So that's why we have cosine times 1 is cosine. Sine times cosine is sine times cosine. Is that okay? The u is just the angle measure that they're using instead of like theta or x. And then for the second one, we need to multiply by sine so that on the bottom we have sine cosine. So cotangent was cosine over sine, and then do that times sine minus cosine times sine, which is right there. And since it's all over sine times cosine, I just went ahead and put it all on top and sine cosine on the bottom. Is that okay? Alright, so we had a plus sine u and a minus this one. Sine cosine and minus sine cosine, those are going to cancel. And then you have cosine over sine times sine. So what's going to happen there? The sines cancel. So we've got cosine plus cosine. So 2 cosine. Over sine u, cosine u. What can we do from there? Cancel out your cosines? Is that what you said? Yeah. So the cosine's going to go away. So we're left with 2 over sine. So what is 1 over sine? So could this just be 2 cosecant?
What do you think?
So what are our questions? Nope, because the cosine's canceled. Yeah, so that's just 2 over sine. And then 1 over sine is cosecant. So just pull 2 to the front, 2 times cosecant. And that's it. Questions? Alright, so we're going to do a lot of these. And we're going to do a lot of practice today, so please don't feel like overwhelmed. So this is basically just tells you how to do them, but I think it's a little wordy. So like I said before, just try to rewrite everything in terms of sine and cosine is what I try to do. And then if it says like establish an identity, that just wants you to prove it. So that's what we're going to do for these. So we're taking cosecant times tangent, and we're trying to prove that it equals secant. So you know where you're going, which I think is helpful, because sometimes it's like, where do you stop? Where do you stop simplifying? But we want to stop when we get to secant. So we've got cosecant. How could you rewrite cosecant? 1 over sine, so we'll say 1 over sine theta times tangent, and what is tangent? Sine theta over cosine theta. So then what happens after that? Your sines cancel, so we've got 1 over cosine. And what is 1 over cosine? Secant. And that's what we were trying to prove, so you're all good. Questions on that one? Alrighty. So if we're looking at the next one, number 2, so we've got sine squared of negative theta plus cosine squared of negative theta equals 1. So this is those even and odd identities that I was telling you about earlier that we did talk about very, very briefly, and I don't remember what notes they're on, so I'm sorry about that. But basically the rule is that if you've got, I'm going to jot it down up here, for cosine of negative x, that's going to be positive cosine of x. And then if you've got sine of negative x, that's going to be negative sine of x. So we're going to use those to help us here a little bit. So for the sine squared of negative theta, we're going to rewrite that as negative sine theta squared. Is that okay? And then for the cosine squared negative theta, the negative is just going to go away. So we could just say that that is cosine theta squared. So then if you have a negative sign, and that's being squared, because cosine is even and sine is odd. Okay. If you've got a negative sign and you square that, what's it going to be? Positive. So that's just sine squared plus cosine squared, that is just cosine squared. And that's a Pythagorean identity at the top of your page. What is sine squared plus cosine squared? 1. And that's what we were trying to prove, so you're all done. Questions there? So the next one, we got a bunch of those negative angles again. So if you have a negative in your sine, we're going to have to pull that out. If you've got a negative in your cosine, it's going to like go away because it's even. So this would be like negative, we'll do the brackets again. Sine theta squared minus cosine squared theta. That's going to become positive, so I'm just going to leave it that way. Then on the denominator, we'll pull that negative out from the sine. So negative sine theta and minus cosine theta. Everybody okay so far? So again, when we square that negative sign, it's going to become positive. So that's going to be sine squared minus cosine squared. And then I'm going to go ahead and factor out a -1 from the denominator. Is that okay? Because we have one there, and it's going to work out nicely in a second if we do. So we've got sine theta plus cosine down there now. And just looking at your numerator, we've got sine squared minus cosine squared. What can we do with that? Any ideas? So think maybe if it was like x squared minus y squared. You could factor that, right? As difference of squares? Yeah? So if it was like x squared minus y squared, what would it factor into?
You
know how to factor difference of squares?
You've got x squared minus y squared. That's going to factor to x plus y and x minus y.
Yeah?
Sure.
That's math 1, guys. I literally am teaching that next week in math 1. Do we really not know that?
Not really.
Awesome. Fantastic. So that numerator is going to factor into sine theta plus cosine, and then sine theta minus cosine. And then we had -1, and then sine theta plus cosine on the bottom. So then that sine plus cosine is going to cancel on top and bottom. So that goes away, and we've just got -1 times sine minus cosine. So you could say negative sine plus cosine, which is the same thing as cosine minus sine, which is what we were trying to prove in the first place. Is that all right? Do we have questions? So we'll go try another one. So looking at number 4 there, we've got a fraction. So we've got 1 plus tangent over 1 plus cotangent. So I would go ahead and try to put everything in like sine and cosine first. So in our numerator, we could have 1 plus whatever tangent is. And what is tangent?
Cosine.
So sine over cosine. And then we'll have 1 plus cotangent on the denominator. And what is cotangent? Cosine over sine. So then you've got to get common denominators in your numerator and your denominator, like separately. So in the numerator, we can multiply 1 by cosine, and then sine times cosine again. Or no, we'll just multiply 1 by cosine. That'll be cosine plus sine over cosine. Does that make sense? So I'm going to do that over here. Cosine plus sine over cosine. And then same idea in the denominator, so we'll multiply by sine this time. So that's going to be sine plus cosine over sine.
What was the first part of that right side say? Like, say something plus sine.
Cosine
Up.
here,
Yeah, that's right.
here,
Right.
here.
Like, your right side of the equation. What does it say?
Cosine u plus sine u over cosine u.
That's,
Sorry.
oh, yeah.
Does that help? So then we're dividing fractions again. So what do you do when you're dividing fractions? We'll multiply by the reciprocal. So I'm going to take the numerator, which is cosine u plus sine u over cosine u times the reciprocal of the denominator, so sine u over sine u plus cosine u. So then from there, the sine u plus cosine and then sine u plus cosine, those are going to cancel. And you're just left with sine over cosine. And what is sine over cosine? Tangent, and that's what we were trying to prove in the first place. Questions on that one? Alright. So we'll move on to number 5. So look at number 5. What do you think we need to do there? If you're trying to add fractions, what do you mean? Common denominator. So you're going to multiply the first fraction by sine. So that's going to give you sine squared. And then we'll have to multiply the second one by what? 1 plus cosine. So that's going to be, I'm just going to write 1 plus cosine squared. Or cosine theta, the whole thing squared. And all that's over sine times 1 plus cosine. We okay so far? Okay, so what should we do from there? Can we multiply this out? Yeah, to the box, multiply that out. So you're going to get 1 plus 2 cosine theta plus cosine squared theta. Is that okay? So you would do the box there. I'm going to try to save you some time. Do we see anything that might be helpful here? So think back to your identities that are on the front. Look up there on the front. See if there's anything that might be able to help right now. Can we just say that sine squared plus cosine squared is 1? And get rid of both of those? Is that okay?
Oh, I mean, I guess you can do that.
I mean, that's an identity right here. Sine squared plus cosine squared is 1. Yeah. So that's just going to give us another 1. So I'm going to like highlight this so we see where that 1 is coming from. So sine squared plus cosine squared is 1. So 1 plus this 1 is going to give us 2. So then you're going to have 2 plus 2 cosine, right? Can I go ahead and pull out a GCF from that? So we'll have 2 times 1 plus cosine. I kind of skipped a few steps there, but that's what's happening. Then what's going to happen? Cancel those 1 plus cosines, and you got 2 over sine. And we did that before. What is 2 over sine? 2 cosecant. And that's what we were trying to prove, so we're good to go there.
So what's the double word?
What do you mean?
She always works.
What's the double word?
If you can't get it to equal that, then you've done something wrong.
Nice.
Because, I mean, if it's prove this and you can't prove it, then, huh? It might be like how you prove it, but like, honestly, I don't know how they're gonna ask you this, like multiple choice. So like, on my test, it was like, just, hey, prove this identity, and as long as your work was like justified, then I gave you credit for it. Does that make sense? So like there's not, have y'all ever heard there's more than one way to skin a cat? There's more than one way to skin a cat. There's more than one way to do all these, okay? So as long as you get to what you're supposed to get to, it's fine. Are y'all from Trinity? Are you sure?
Oh,
You've
yeah,
never
we
heard
are.
that?
Never heard that in my whole entire life.
You've been living under a rock.
Yeah.
All right, so can we try another one?
Sure.
Okay, so looking at number 6. I don't,
It's so stupid.
Josh, what do you use theta instead of v?
Yeah.
Is that fine? Okay, we can do that. That's fine. So we've got tangent plus cotangent. So let's rewrite that in sine and cosine. So tangent is what? Sine over cosine plus cotangent. What is that? Cosine over sine. And then on the bottom, we've got secant. What is secant? 1 over cosine
Nice.
times cosecant, which is what? 1 over sine.
A lot of.
There's a lot of stuff going on there. So in our numerator, what do we need to do? Or what do we need to get?
Common denominator.
Common denominator. So you're going to multiply this one by sine, so that's going to give you sine squared. And you're going to multiply this one by cosine, so that's going to give you cosine squared. And on the bottom, you're going to have sine times cosine. And can we go ahead and multiply by the reciprocal here?
Yeah.
Yeah, so I'm going to say times sine theta cosine theta over 1. Is that all right? So sine times cosine, what happens? They go away. And we just talked about sine squared plus cosine squared. What is that? 1. So this whole thing is 1. Is that okay?
Hey.
Questions?
Oh. No.
Are they getting easier?
That one was easy.
That one was easy? Great. Just wait till we get to the next one. It's even better. All right, so looking at number 7. Now, like I said, there's more than one way to skin a cat. So I would say that this, is probably not the right way that I'm getting ready to show you, but it works. So if you ever have, a fraction equals a fraction, what's, y'all's instinct to try to solve that? Cross multiply, right? That's exactly what I would do. So when we multiply 1 minus sine times 1 plus sine, what do you get?
X squared minus y squared.
Yeah, so 1 minus sine squared, because 1 squared is still just 1. And then you're going to have cosine times cosine, which is what? Cosine squared. And that's an identity, right? That's your Pythagorean your Pythagorean identity. We could move that sine squared over so it looks more like the one that you have. So you could say 1 equals sine squared plus cosine squared.
That works.
And that's true, so you just proved it. Is that all right?
That's too easy.
So yeah, on 8, we've just got to simplify that. So anytime you've got a binomial times a binomial, what should you do?
Box.
The box. So when you multiply that out, what do you get? So kind of like the same way that we did here.
Sine squared x, same thing.
Yeah, cosine squared x minus 1. Because negative 1 times positive 1 is negative 1.
Yeah.
And that's an identity as well.
Yeah.
It'll be negative sine squared, right? Because the identity, I'm going to write this on the back. We got sine squared. So we could subtract cosine squared over, right? This is the identity that we're working with to try to get something that we could replace that with.
Oh.
So you got 1 minus cosine squared, which is fine, but it's not the same as this, correct? So how could we make these the same? Negative 1, so we could just say negative sine squared of x. Is that okay? And that's as far as you could go on that one. So I almost think that these are a little bit more challenging just because you don't know what you're working towards, but still not too bad. Questions?
No. Is it homework or classwork?
Yes.
Okay. Both?